In this lesson, we will solve some logarithm problems. Before we dive into the problems, let us first look at few things. If you remember, we have already discussed that if a power x is equal to y, that can be represented in a logarithmic notation as log y to the base a is equal to x. So if a power 0 is equal to 1, so x is 0 and y is 1 in this case, we can write that as log 1 to the base a is equal to 0 based on this notation. So what this means is log 1 to any base where a is greater than 1 is equal to 0. So this identity holds true for a greater than 1. So basically what we are trying to say here is log 1 to any base which is greater than 1 is always 0. So this is one thing that you would have to remember. So talking about bases, logarithms are generally represented in two types of bases. One is base 10, the other one is called base e, which approximates to 2.718. So any logarithm which is represented as base 10 is called standard logarithm, and it is represented as log x to the base 10 or simply log x. Whereas a natural logarithm, which is represented with the base e, is sometimes represented as log x to the base e, but this notation is very rare. Generally, we represent this as ln x. So where ln is natural logarithm. So now equipped with this information and the laws of logarithms, let us try to solve some problems. Now let's work on the first problem. You have been given to find the logarithm of 81 multiplied by 729. So if you remember the formula, log xy is equal to log x plus log y. So this can be expressed as log 81 plus log 729. 81 is nothing but 3 power 4 and log of 729 is nothing but 3 power 6. But we also know that log m power n is equal to n log m. So here log 3 power 4 is in the form of log m power n. So this can be expressed as n log m, which becomes 4 log 3 plus similarly here 3 power x is nothing, in the form of m power n. So this becomes 6 log 3. So 4 log 3 plus 6 log 3 is nothing but 10 log 3. So log 81 times 729 can be simplified as 10 log 3. The next problem that we will solve is we have to expand this expression. So let's first try to simplify this algebraic expression, which is square root of x cubed by y square. So this is nothing but log of x cubed by y square whole power 1 by 2. This is in the form of a power m whole power n, which is nothing but a power m times n. So this becomes log of x cubed by 2, because 3 times 1 by 2 is 3 by 2, by y square times 1 by 2. 2 and 2 gets cancelled and it will be simply y. So log of square root of x cubed by y square is nothing but log of x power 3 by 2 by y. But this is in the form of log of a by b, which is nothing but log of a minus log of b. So this expression here, which is log x power 3 by 2 by y, can be expressed as log of x power 3 by 2 minus log of y. So again, if you observe, this is in the form of log x power m. So we know that log of a power m is nothing but m log a from the laws of logarithms. So this can be expressed as 3 by 2 log x minus log y. So this is the expanded form of this expression, log of square root of x cubed by y square, which is nothing but 3 by 2 log x minus log y. The next problem that we will solve is actually we will prove a statement which is minus ln x is equal to ln of 1 by x. So this is natural logarithm. So the laws of logarithms that we have discussed so far can be applied to logarithms of any base, irrespective of whether it is a standard logarithm with a base 10 or a natural logarithm with a base e, or as a matter of fact any other base. So let's first try to take the left hand side over here, and as you see, minus ln x is nothing but minus 1 times ln x. So if you recall from the laws of logarithms, we know that log of a power m is equal to m log a. So over here we have the expression as m log x. So this can be expressed as ln x power minus 1, right? Because m over here is minus 1 and x over here is a. So that can be represented as log of a power m. So log a, which is x, power m, which is minus 1. So ln x power minus 1. So x power minus 1 is nothing but 1 by x. By applying the law of logarithm, we are able to prove the left hand side is equal to right hand side. So finally, let's try to solve this expression. So we have been given 3 log 2 plus 5 log 3 minus 2 log 5, and we have been asked to simplify this expression. As a reference, I have listed all the 3 laws of logarithms that we have learnt. So if you look at the first term, it is in the form of m log a, right? So that is nothing but log of a power m, where a is equal to 2 and m is equal to 3. So this can be expressed as log of 2 cube. Similarly, the second term can be expressed as log of 3 power 5 minus log of 5 square. So we have applied the third law and we have simplified these terms. Now if you look at the terms, first two terms, it's in the form of log a plus log b, where a is 2 cube and b is 3 power 5, and this is nothing but log ab. So we can simplify this as log 2 cube times 3 power 5 minus log of 5 square. So this is now in the form of log a minus log b, where a is 2 cube times 3 power 5 and b is 5 square. So this can be simplified as log of a by b. So let's write that down. So log of 2 cube times 3 power 5 by 5 square. So which is nothing but log of 8 times 3 power 5 is 243 by 25. So this can be further simplified as log of 1944 by 25. So 243 times 8 is 1944 divided by 25. So we have simplified this expression into a single logarithmic term. So in this way, we can apply the laws of logarithms to simplify equations which involve logarithms.